Okay, so now we're going to learn about partial derivatives. So we're in multivariable calculus territory, which is partial derivatives. You might be wondering, do we use u sub here the same way we do irregular derivatives or intervals? Technically, we don't do u sub the same in the same form way, but we use a similar mindset when we're differentiating composite functions and multiple variables, especially when we apply the chain rule for partial derivatives. So how does this happen, or when does it happen? So let's just say you have a function like z f x z and then x and y, right? But x and y are each functions of another variable like t. So you need to take a partial derivative of z with respect to t, even though t isn't directly in the original equation. That's where multivariable chain rule comes in. And this is where the use of almost something like use of kind of comes in. So let's just say z equals, again, f. I guess we don't really have to rewrite it. Yeah. So I'm just rewriting it for clarity. F of y. And so x is x of t, like I said, and then it's going to be yt, right? So then it would be dz dt, and then it'll be that of f of x. This is like the way that we write it in our textbook. So it's like this, x times, let's just say dx dt, as this is the um, derivative of this, plus this weird thing, f, and then y times dy dx. Oh, it's only x, this is not y. Okay, so let's do a simple composite function. So we can do, okay, we do this. Uh, just equals x squared y plus y to the third. So we want dz dt. So we need to apply the chain rule of partial derivatives. So we want to find the derivative of v. So then that, my guys, that's going to be. So we're going to start with. Let's start with 2 for now. Yeah, okay. We'll start with finding x first. So when we're doing this, we want to just focus on one part. So right now I'm just going to focus on x. So I'm focusing on this. So just take the derivative of x. So anything you see x, take the derivative of it. So this is going to be 2x. And then we have a y, so we're just going to do that one. Y over here is by itself. It's so that means we can just cut it out. So now we have dz. Let me say dz dy, but we just found the derivative of z for the first part. Now we want to do it for y. So c, the same thing. So we have. So let's just okay. Yeah, we're gonna let x squared be by itself, but we have a y right here. This is our y. Take the derivative of that. That derivative of y is just going to be 1 because there's nothing attached to it. So leave that alone. And we do the plus. And then that's just going to be the derivative of the y because we're focusing on only taking the derivative of the y. So y, 3y squared. And yeah. I mean, usually they just ask you to find things separately, but you can do it again. Uh, yeah, so that's finding, we're just finding each part. So let's try it with the square root function. Or, you know what, we can do, we can do it with the exponential function. What do you think? Okay. Let's see. Okay, so we're gonna try to find something with an exponential function. So this is what they're asking. Squared plus 3y. So we're just gonna do this step by step. So let's just say they're asking me to find x and y. So remember, we're doing this each part. So number one, take the partial with respect to x. When we take the partial derivative with respect to x, we treat y with a constant. So we leave the 3y part alone and only focus on the x. So this is going to be funny because we're working with the exponent, we're working with e. And that's just going to be essentially, we're going to take the derivative. Oh, this is all an exponent. This is like confusing. So the derivative of eu is just eu times prime. So if we write that out, so eu is just eu and then times e prime of that. In this case, u is 2x plus 3y. And since we're taking the partial with respect to x, since we're finding respect to x right now, the derivative of u was just 2. So that's just going to be e. Remember, keep this the same as it was through y, and then the derivative times 2. Rewrite this. This is just 2 exponentially 2x plus 3y. Now let's do the same thing. Partial derivative sets to y. So remember, it's the same idea here. We treat x like a constant and take the derivative with respect to y only. So dy, dy. y. Again, the derivative of the exponent is just 3, so we get 2. I'm just going to rewrite this again. Times 3. This was 30. This is going to be 3. 2x plus 3y. Yeah, it's honestly that simple. Yeah.